Hi everyone, Joe here. Welcome back to Data Science Building Blocks. We have wrapped up the first unit in Excel and now we are moving on to R, which is widely known in the statistics world and used as another object-oriented programming language. We started R in video number 9, so we already have R installed and RStudio installed, but if you don't have it, go back to watch video number 9. We do it right in the beginning. I don't think we saved a worksheet, so just go ahead and open up RStudio by doing the Windows button and RStudio, clicking enter, or if you have a shortcut on your desktop, go ahead and open it up. You'll likely see a blank screen. This is just the piece of code that we wrote last time to grab the mtcars data set from R, but rather than do this again, I'm just going to comment it out by putting a hashtag or number sign right in front of it, and now we can actually just grab mtcars by doing data and mtcars in quotes, and I'm just going to control enter every time I want to run that one line. And I'm going to help you get a lay of the land here, so you can see that this is where I'm doing the coding. You can call this your source pane up here, this top left corner. This section down here is your console. It works a lot like Python. If you've seen that, you can code directly in here, but you won't be able to save your code. Up here is your environment. This is where your values are stored. This is kind of like a variable in Python. So if we set something equal to something else, like in Python it would be x equals 3, but in R we use this operator, which is a left arrow key and a dash or a hyphen, and 3, I'll do control enter so you can see x is 3 over here. This is where you will store all of your values in this environment pane in the top right corner. And then this last section here in the lower right, it's your multi-tool pane, and you can do a number of different things like access folders from your computer, see your packages, get help, etc., etc. But we're going to focus up here and actually go ahead and do a file, save as, and I have everything still on my desktop. So if I go to desktop, data science building blocks, I can do this dsbbr and save. So now you can see I'm actually saving this notebook, so I'm saving what I'm doing up here in our source pane console. So I'll continue writing some code up here in the source pane console. So I'll start off just by viewing this, what I'll call a matrix. We have mtcars here. You can just double click it and you can see that it appears down here. The code is view mtcars, and then you'll have it pop up right here as well. And this looks like it did in the Excel file when we extracted it to a CSV file the first time, and this we've already worked with this exact data. Of course, it doesn't have any of the columns that we saved in the previous video. This is just the raw data straight out of R in this matrix. I can close this out here. It's stored over here, and again, like this is, I like to think of it like an object, but R really isn't an object-oriented language like Python. It's classified as a functional programming language. However, it does have a lot of the same principles and makeup and feel to it when you're defining values and using this assignment operator like we did above here for x equals 3. If I do x equals 5, you can see it replaces the value here, and I'm just doing control enter to run it. So you can do the view mtcars to see that. You can double click it, just to show you again, mtcars, control enter, and this will bring it up for you. So I'll exit out, and now let's actually work with the data a little bit. We're going to go over some filtering, some sampling of rows, working with the tidyverse library, making some new tables, summarizing the data, etc. Just basic things that you'll need to know how to do if you have data stored in your environment over here. So first thing, let's just select some of the data. So if we do mtcars and then open bracket 5.1 bracket control enter, you can see down here it's giving me 18.7, and it's storing it nowhere because we're not we're not using that assignment operator anywhere. We can double click into this to see why it's giving us an 18.7. If we're doing 1.5, it's doing the first column and then down 5 rows. So here we're getting the Hornet Sportabout MPG number. So that's how we move through the columns. If we want to, I'll keep that code. If we want to filter the table, we can do something like filter table. I'm just going to call it filter table. Do the assignment operator. Now we'll actually store this value, or store this filter table as a matrix. And we can do mtcars cylinder. So here we're selecting the cylinder column from the mtcars data over here. We use the $sign to do that. And we can filter it. That column is greater than 4 if we want everything 4 cylinders and above. And instead of selecting just the first column, we are just going to select everything. So we'll leave this blank, and then we can just do Control Enter after we do the close bracket. And you can see it's generating code down here, and it has given me now 21 observations of 11 variables. You can just single click this. If you single click it, you'll see that we don't have anything under 6 cylinders. There's no 5-cylinder cars. All the 4-cylinder ones have been filtered out because we told it to filter out the 4-cylinder ones here. So that's how we'd filter. We can do another table and filter by multiple criteria. So filter table 2 gets, and this time we'll use the subset. And you can see the IntelliSense is working here. It's giving me a little info. I just clicked tab, and now I've selected this function. So we can do mtcars as our first argument, and then we can do cylinders greater than 4. And remember, now we're not referencing this filtered table. We're going back to the raw mtcars. And we can do gear is exactly 4, just for example. Control Enter. Now we have another data over here, and if I click it, you can see there's only 4 records out of the 32 where the criteria is met. So we have this new table stored. Next thing, if we want to store the number of rows, we can store it in nrow, and we can go 1 through, use this nrow, and we can do it on filter table 2. I'll just double click it. So now I have the integers stored as values under this nrows over here in the environment. So this is helpful if I want to just select the total number of rows and store them as a vector of integers, kind of like a list in Python. It'll help me like iterate through the table later, or just use that total number in some other function. So continuing on, like for example, if we do sample rows and we want to sample out of the total, so num_rows, and we'll say 3, Control Enter. Well, now this has taken a sample from the first 3 numbers in this list of 4, or actually just any 3 numbers out of the list of 4. We're sampling 3 out of the list of 4, and it's technically called a vector, but that's what it's doing here. Now if we actually want to filter a table, like if we go back to using filter table 2 and just do sample rows, so we'll take the sample rows, which is 3 numbers, comma, and then everything, do a Control Enter now, and you can see you get some data here. It's only taking 3 out of the 4, and it's generating a sample for you. So that's where these 3 lines could come in handy if you wanted to do something like that, if you're working with a much larger data set. before we go any further, and actually if you were unable to run any of that code, it's possible that you didn't do a library tidyverse. We're going to want to bring this in, so I just did a Control Enter on that again, and if you haven't installed it before this, which you may not have, you'll want to actually do this line of code here that I'm about to paste, install.packages tidyverse. And then you can run library tidyverse and it'll bring it into your notebook. So I'll actually place this, since we're all saving these workbooks, I'll place it above here and I'm just going to comment it out for me. I've already done the install, I'm just bringing it into the mix here. So next thing, let's do a new table. And let's take table 2, and what we're going to learn now is this, it's called a pipe, and we use it as an operator to chain functions together. So in this case, we're going to use the mutate function, and let's just create our own column here, and we'll just do something like horsepower per weight. It's not a lot of good columns to use for math here, but what we're doing here is we're going to divide like 110 by 2.6 and 110 here by 2.8 all the way down the line. So we're going to add this column, horsepower divided by weight, so HP divided by WT, those are the column names in the table. And we can add just an isActive equals true. Control Enter. We have this new data here. If I click new table, so now I have this 110 divided by 2.6 is 41.98, and the isActive equals true column. So we've just used the mutate to add in 2 new columns that we just now created, and we use this pipe operator to add it to the existing filter table 2. So continuing along these same lines, let's learn the summarize function. So if we do summarize, I'll just call it summarize demo. mtcars, we'll go back to the raw data source here. Use this pipe operator and group by. This is where I think you'll need tidyverse to do this. So we do group by cylinders, for example, and we'll do another pipe operator, and we can use the summarize function. And here we're actually going to make another new calculation, so we'll call it mean mileage. Since we're summarizing, we actually need to give it some math here, and we'll do mean of miles per gallon, which is a column in the data set. So taking the average, calling it mean mileage, and we're going to group by cylinder, and it's everything in the mtcars. So when I run it, I'll get something that looks like this. So we have 4-cylinder cars, 6-cylinder cars, and 8-cylinder cars. What this is doing is taking the mean of the MPG column for all 4-cylinder cars in the mtcars dataset. And one more thing for today, let's show you, I'll call this long table. We'll store this one as well using the gather function. So if I use gather, use mtcars again, you'll notice that we usually start with the data set. We can call these columns whatever we want. We're going to do a key and value column. This function is basically like unpivoting something, which we will visualize later on in Power BI. Let's just call key equals metric and value equals score. I'll take the space out just because I didn't put a space after key equals, but it doesn't matter. You can put a space there if you want. And here we can select one column, all the columns. It doesn't matter, it's just whatever you want to unpivot. So why don't we just select all the columns, which would be MPG all the way through carb, so everything. If we put a colon and do it like this, this will select everything, and then that's it. That's all we need to do. Control Enter, click on long table, and you can see what we've done here. We've basically taken the header for every column, put it in this metric column, and have listed all of the values underneath that column. So unpivoted the original data set. So we've made cylinder itself a record under the metric column. We've done the same thing for miles per gallon, disp, HP, DRAT, all the way to carb. We've made these headers values under the metric column, and then we've made all of the values currently under them values in their own column. And you can see now that we have run this and are visualizing it, we have 352 observations. So that's all I wanted to show you today. Go ahead again and save this, and next time we'll do some plotting in R. So I'll see you then.